Welcome, everyone. Today we're diving straight into a really timely piece of research. It's called New Kid in the Classroom, Exploring Student Perceptions of AI Coding Assistants.
And we should just get right to the findings because they are pretty stark.
Absolutely.
So first, students in these intro programming courses, they see AI assistants like Perplexity and ChatGPT as a massive boost. They feel it helps with efficiency, with speed, and it really does help them with debugging and just getting code on the page.
They feel faster, and the data actually backs that up.
It does. But, and this is the big but, the study had this really clever two-part assessment. First with AI, then without.
And that second part is where it all comes apart.
Exactly. When that AI support was taken away, even for simple tasks, students just, they really struggled. It points to this huge risk of overreliance where they just aren't transferring that foundational knowledge.
So that's the core tension, right?
That's it. For anyone listening, whether you're an educator or you're actually building these models, the big takeaway is we desperately need teaching strategies that force students to adapt and really understand the AI output. To stop them from just, cognitively offloading the work.
That perfectly sets up the gap this study was trying to fill, because so much of the research we've seen is on, professional developers, or it's in these really controlled lab settings.
Right.
This one is different. It's looking at novice programmers in a real, live, introductory, object-oriented programming course. This is the front line.
And the demographic is just fascinating. We're talking about 20 undergrads at the District University of Bogota. And critically, most of them call themselves basic-level programmers.
So this is the exact group that might see AI as a kind of magic button.
And that makes them the most vulnerable to, skill atrophy. They haven't built up the fundamentals yet.
So how did the experiment actually test for that? For skill atrophy versus real learning?
Well, the design was a case study, and it had 2 sessions, a week apart. Session 1 was all about efficiency.
The with AI part.
Yep. 90 minutes. They had to build a complete Java application, something called a movie billboard problem. And they could use any AI assistant they wanted. Perplexity, ChatGPT, Grok, whatever.
And then session 2, the moment of reckoning, you could say.
That's a good way to put it. It was the unaided knowledge transfer task.
Much shorter, right.
Much shorter, just 30 minutes. They just had to make some simple extensions to the code they'd already written. But the key rule, the absolute rule, was no AI.
So it's designed to surgically measure that shift, right? What happens when you pull the safety net away?
Precisely.
Okay, so before we get to that shift, how were they even using the AI in the first session? Was it just, write me the whole solution?
Not really, no. Their usage was actually more focused. The main reason they used AI was for debugging, by a long shot. After that came code explanation, and then finally code generation. So they were really using it like a super fast, infinitely patient pair programmer to catch their immediate mistakes.
And what about the specific tools?
Perplexity was the most common, followed by ChatGPT, which kind of suggests that these novices are prioritizing tools that are known for, quick, factual code retrieval and error correction.
Okay, so let's look at the results from that first session. The students obviously felt pretty good about it. What did the numbers say was the biggest gain for them?
It's crystal clear. Speed. Their overall AI usage was rated as moderate, just over a 3 on a 5-point scale.
Okay.
But the rating for their perceived gains in speed, that was way higher. It clocked in at a 3.65 with a median of 4. They felt way, way faster.
And we're not just taking their word for it. Did the research actually validate that feeling?
Oh, absolutely. The researchers found a really strong, statistically significant correlation between using the AI more and feeling like they completed the task faster.
And what does strong mean here for our listeners?
Well, the correlation coefficient was 0.64. That's a very robust finding. It confirms it. The more you use the AI, the more you genuinely felt you were just having through the task.
So that gives us our first big insight for you, the listener, doesn't it? For novices, AI is an accelerator, first and foremost.
It is. And when you contrast that with the other metrics, it really drives the point home. Think about this. Their conceptual understanding only improved moderately at a 3.25. And that was all over the place between students.
And what about exploring different solutions?
Rated neutrally, actually below the midpoint of the scale. So for a novice, the AI isn't this deep learning partner or an exploration tool.
It's a high-speed error corrector. It's like using a calculator on a math exam. You get the answer fast, but you might be skipping the very process you need to actually learn.
That's a perfect analogy, and it raises the main big question. If the AI is handling all those little frustrating details, the syntax, the error messages, are the students actually engaging with the code it produces? Or are they just copying and pasting?
This is where the qualitative data comes in.
It is, and it gives us a little flicker of optimism. Most students did actively modify the code. When the researchers looked at the answers about code adaptation, the top category was refining and restructuring. 10 of them said they changed variable names, added comments, that kind of thing.
Okay, but I have to jump in here and challenge that a little. Is changing a variable name or adding a comment, which is, let's be honest, often just a cosmetic fix, is that really critical engagement?
And that is the absolute heart of the issue for educators. That's the distinction. I mean, some students, 6 of them, did report a deeper level of engagement, like simplifying AI solutions that were too wordy.
Okay, that's better.
But the majority, you're right, it was more like superficial editing. They were acting as editors, but you have to question the depth of understanding behind those edits.
And their confidence. Did feeling fast translate into being confident in the work?
It was mixed, which kind of confirms that ambiguity. 7 students said they had a clear understanding, but they often pointed to their prior experience with Java or C++.
But what about the others?
A really interesting group, 3 students, actually had to proactively ask the AI to explain parts of the code it had just generated.
Wow. So they're using it as a just-in-time tutor because the code it gave them was maybe a bit over their heads?
Exactly. And the confidence numbers show this. 7 felt high confidence, but another 6 admitted to having only moderate confidence, with doubts.
What were they worried about?
Hidden errors, inefficiencies, or just concepts baked into the code that they hadn't really grasped yet. That skepticism is healthy, I think, but it shows they weren't fully in the driver's seat.
So they felt fast, but a lot of them were still worried about this black box they were submitting. Okay, so now let's get to it. Section 2, the stress test. What happened when the crutch was taken away?
And this is where all those efficiency gains just curdle into a dependency problem.
Oh.
When they were asked about their unaided ability to solve the extension task, their confidence just evaporated instantly. Only 15%, that's just 3 students, felt completely able to do it without AI. Half of them felt only moderately able.
That's a huge drop. But the researchers point to something even more dangerous here, something about cognitive offloading. We should probably define that.
Right. So cognitive offloading in this context is when the essential mental work, recalling syntax, figuring out logic, debugging, is habitually outsourced to the tool.
The tool isn't a helper anymore. It becomes the primary holder of that knowledge.
And the student's own brain just doesn't build that muscle. And the scariest finding here is that the students had no idea this was happening to them.
What do you mean?
In their self-reports, they described the unaided part as only moderately difficult. But the instructors watching them said they were visibly struggling, sometimes failing to do really simple things. They didn't realize how much they were relying on the AI until it was gone.
That is genuinely dangerous. If you don't know what you don't know, how do you even begin to fix that?
Exactly.
So what were the specific fundamental skills that just didn't transfer?
It was surprisingly basic stuff. The primary issues for 6 of them were syntax and language-specific problems. They were tripping over the absolute fundamentals. How to use a Java method, where to put a semicolon, basic language structure.
For anyone listening who's a seasoned developer, forgetting a semicolon sounds trivial. But for a novice, that's the kind of frustrating detail that AI fixes instantly.
And if the AI is always handling that friction, you never build the muscle memory for it yourself.
That makes sense.
And 4 other students also said they just desperately missed that instant feedback loop for debugging. They were used to an instant fix or explanation, and suddenly they were just stuck, staring at a compiler error with no idea what to do.
The AI did all the painful work for them, which is ironically how most of us actually learn to code in the first place, through that painful repetition.
And that leads to what the paper calls the transfer paradox, where the help they got earlier actually became a hindrance later.
Okay, this is a deep dive nugget right here. Explain that.
Well, while some students, 6 of them, felt the AI gave them a good conceptual scaffolding to build on, 3 others found that the code the AI generated in the first session was just too advanced for them, too confusing.
So the AI over-optimized the solution.
It gave them a Rolls-Royce engine when all they needed was a bicycle. And now they can't even fix a flat tire because the initial complexity just overwhelmed their foundational knowledge.
Their foundation was built on sand.
Completely.
Okay, so given all this, the efficiency gains followed by this stark cognitive offloading, What are the real concrete takeaways for educators and for the people actually designing these systems?
The students themselves had some pretty pragmatic ideas. When they were asked about AI's role in learning, 75% agreed it's useful, but they weren't naive about it. A big majority, 60%, stressed that you need coding skills to adapt the AI's output.
So they get it. It's a tool, not a replacement. You can't just be a user, you have to be a critic.
You have to be a proficient editor, yeah.
And what did they think of the exam itself, the structure that forced them into this situation?
They actually liked it for the most part. They found the two-part exam to be well-structured and really effective at testing their ability to modify code, even if that code was originally 100% from an AI.
That's a huge signal for instructors, isn't it? Maybe assessment needs to shift from just pure code creation to this critical review and adaptation of existing code.
I think so.
Looking forward, what did they want to see in their courses? They want the tool, clearly, but maybe with some guardrails.
They do. The most common wish was for AI to be used as a support tool, mostly for debugging and getting quick answers. It fills that need for an efficient error checker.
But not everyone agreed.
No. A significant group, 4 students, explicitly said they'd prefer no AI in their courses at first.
Yeah.
They argued for traditional teaching to make sure they get that deep conceptual mastery before they're handed these powerful tools. They see the danger.
Which points right to the mitigation strategy the researchers landed on.
It does. The study concludes that instructors just can't let AI replace active practice. They have to design activities that force students to critique or simplify or refactor AI-generated code.
You have to force them to trace the logic and internalize the knowledge.
Otherwise, you get that dangerous cognitive offloading.
So to just wrap up the full tension here, AI offers this huge, measurable efficiency boost for low-level tasks, and that feels amazing to a novice.
Right.
But that efficiency comes with this massive trade-off. You might be inhibiting the development of core skills, syntax, logic, basic debugging, when that safety net is gone.
And if we connect this to the bigger picture, for everyone listening who's building or using these tools, if generative AI gets really good at handling syntax and basic debugging, which is exactly where these students fell apart without it, then we have to ask a really big question.
Which is?
Will the curriculum itself have to evolve? Will it need to prioritize high-level critical review of code architecture and maybe prompt engineering over just rote syntax mastery?
That raises a really provocative question about what foundational knowledge even means in the age of AI. Can our educational systems even define and test for those new skills before a whole generation of coders starts building really complex systems on foundations they don't fully understand?
We need to be ready to measure not just how fast someone can code, but how deeply they can critique what a machine has built. That's the challenge for all of us moving forward.